Well, well, well. Hello, everyone, and welcome back to my channel. Today, I am going to be. Oops, sorry. Hearing myself on echo is one thing. But I am going to be testing o3-Pro for the first time. I'm actually just going to post this on X. Trying o3-Pro. Problems. Sorry about that. I'm always the first person to. I'm always having to post for myself on like X and stuff and putting the announcements up, so I apologize. But I have not tried o3-Pro yet. This is my first day with a brand spanking new Pro subscription to OpenAI because it's been a while and it's very expensive. But the hype has gotten me curious. And so, you know what they say, curiosity killed the cat. So I guess I'm the cat here. Maybe I'm Schrodinger's cat. Who knows? I did want to do some quantum mechanics tonight as some of the tests because I have been really getting back into quantum mechanics, and it's been a while since I have really thought about it. Like I've probably forgotten more quantum mechanics than most people ever bothered to learn. So that'll be interesting. A couple of things though. We have some standard benchmark questions that we can give it. Also have some questions here, some standard ones that we've done in the past. So this one is Ahmed's integral, actually. And I'm curious to know if maybe it can do this. You know, perhaps it's that smart that it just knows how to do this. Let's see. Let's see, you know, let's just see if it can take my screenshot. It's supposed to be super smart, so I'm just going to give it my screenshot and be like, hey, I need you to evaluate this integral here, please, o3-Pro. Evaluate this integral. Do not use numerical integration. Let me see this integral analytically without using numerical integration. Just as a way to stop it from using any special tools, we're just going to make it use normal calculus, basically. So, all right, let's see. We know the answer is 5 pi squared over 96. Can it get it? Well, its predecessors could, so I would be kind of surprised if it didn't. Will it even know that it's Ahmed's integral? That's another thing, actually. Still reasoning. It is still reasoning. Okay. Hello, Luther Obama and Jacob Shank. Good to see you all in the chat. Still no details. Okay. Guess we're just going to wait. This is kind of new. I haven't seen it reason like this before. So this is kind of exciting. This is a new model, a new day, and a pretty tough integral, if I do say. It says here, it took like 10 minutes to respond to hello, so you're going to be here for a long time. Oh boy, okay. Thinking subproblem through. Okay, it says, I'm examining substitution root 2 tan u. This seems to simplify the integrand. Okay, so I guess we are going to be here for a minute. And while it thinks, I guess I'll talk to you a little bit about what I have planned with these models for the foreseeable future. So I have been deeply interested in becoming decent at physics again, which is probably something odd to say, but if I have to be an honest evaluator of my ability to do physics, now that my physics PhD is behind me and I don't work in physics anymore, it's gone down quite a bit. It's gone down quite a bit. And so I'm hoping to use these more powerful models to really help me relearn aspects of physics that I really want to get good at again. And one of the areas that I really want to get good at again is the field of quantum mechanics. And so that is something I definitely want to try and push not just these models, but myself on, because it's going to force me to actually get good at doing quantum again, which it's been a long time since I really felt like I had a good handle on the subject. I mean, it's not an easy subject to confront, I think, and especially one if you walk away from it for a while. So I think this is where I'm going to be for a bit. We're probably going to be using quantum mechanics questions a lot, so I apologize if it's kind of abstract and dense, but I'll do my best to try and explain some things, because I was working through a quantum mechanics problem today that I'm very proud to say I actually got right, and it was in this notebook here. And these models are getting really good to the point where basically I will do a problem and then I might get stuck, and then I'm like, I don't really know how to continue. Can you give me some pointers as to how I should continue? And then these models can give me a really good piece of advice as to like, oh, you need to consider this, or you need to rewrite that term as this, and then you can keep going, that kind of thing. So I'm going to try and give it a question I did today in quantum mechanics, which is not, I don't think it's that hard of a question, but I'm curious. It's a question I haven't given any other model yet, and it's from a very old book that I don't think is just sitting around anywhere. So we are going to take our time here. But in the meantime, well, maybe I can explain the problem that we want to do next here. So let's keep this up here, but I will also, I don't know if I can do both at the same time. So right now we're doing this problem here. But effectively, this problem that I want to do next involves this thing called the Bohr-Sommerfeld quantization, which is like the semi-classical thing. But effectively, the problem that I want to solve is, it looks something like this. So it involves integrating the canonical momentum of the system. So that's just, you could just think of it as normal momentum with position is equal to nh. And this was like an old, this is like an old quantum theory approach of figuring out the discrete energy levels of a system. And so the problem that I want to give it is this problem from this book that I did today, which is kind of interesting. Essentially, it involves a ball falling from a height, and it's going to have an elastic collision with the ground, and then basically come back up to the same spot. And the way to do this problem is that you have to rewrite the momentum and the position in terms of this setup here. And in fact, I'm going to call this direction the z direction here. So I'm going to spend time working through some of these problems just so I can be confident that I know how to do this. But effectively, this is known as the Bohr-Sommerfeld quantization. And yeah, I want to see if it can get this problem. So what is this problem even asking? So the problem, again, is just asking what are the potential energy levels that this ball can have, right? And if you use this sort of semi-classical, is what they call it, the semi-classical approximation, is sort of a bridge between classical mechanics and quantum mechanics there. Sorry, I'm just taking a look here at o3-Pro, see how it's doing. And the way that this problem goes is that, again, maybe I shouldn't spend too much time explaining all the nitty-gritty details. Effectively, the way to think about it is that this ball is going to start at, let's say, a height z, and that the potential energy, or the energy at this place, is going to be equal to mgz. That's the potential energy. And effectively, what you need to do is rewrite the momentum as the following. So, or I should explain this in a better way. I'm sorry, I'm kind of going all over the place. It's been a while. Give me a sec. So, total energy is equal to p squared over 2m. That's kinetic energy, and then you can also add the potential energy as well. And so what we do here is that if you solve for p, you get something that looks like this. So E minus mgz. And then you have to integrate. You have to stick this into this spot right there, and then basically you want to integrate this over a full cycle. So you're going from basically z to 0. So this is 0 here, back to z. So the way to do that is just to well, you effectively just need to rewrite this in terms of this expression here. So I'm going to be skipping a lot of steps here, but effectively you get to this integral. And you're going from 0 to, effectively you want to figure out how high this thing can go, right? So this thing is at mgz, and z is the max, right? Z is the max height at this point here. Then the max height in terms of z is just equal to E over mg, or the total energy over mass times gravity. Okay, so anyways, we want to do this integral, basically. That's effectively what the problem involved, and I was happy to say I was able to actually get this. And so if you spend the time to integrate this all out, it's not that hard of an integral to do, actually, if you think about it. I know it looks kind of messy. Let's see here. Kyle, if you see this, test it on organic chemistry in binomenclature and IUPAC naming. I have an organic chemistry book behind me, so I'm going to go grab one, even though I was specifically just going to do physics today, but I will get the organic chemistry book real quick. Where is it? Ah, here it is. I don't know if anyone has this book, but the Organic Chemistry as a Second Language book. Curious to know if it can do it. I don't know anything about organic chemistry, so let's see here. How the heck? What should I give it here? Conjugated double bonds. Let's do like a naming one. Let's see if it could actually get... I think the first section is on naming. What is a resonance? You tell me. Should probably just find something to name. Carboxylic acid. Acid-base reactions, nomenclature. Okay, here we go, nomenclature. Functional group, naming the parent chain, common names. Okay. 84, so let's just go to here. Oh, that looks kind of ugly. 2-chlorohexane, 3-methylpentane. All right, so yikes. All right, I guess I will try and give it a organic chemistry question, just because I'm kind of curious myself. But after this integral. The integral first, and then we figure out how it's doing. Mapping out the steps. Oh, it got it. Yo, actually. Oh my god, it actually got it. Well, at least it got it in the reasoning steps here. So it got 5 pi squared over 96. Yo, this was a tough integral in the past. I mean, it is still a tough integral for a human, but it looks like it's going to get it because it gets 5 pi squared over 96. Pretty good. Pretty good. I am going to set up a organic chemistry problem, basically. And we just gave it the screenshot, too. That's like the crazy part, too. Let's see. Okay. Let's see if I can draw one of these structures. If there are multiple subs, then it must be numbered. Trimethylpentane. Oh, gosh. Let's prove that pesky Riemann hypothesis. That would be a good one, wouldn't it? Martini 1179, if we could just get it to prove the Riemann hypothesis. So it basically got this one. So, okay. I'm going to go ahead and draw this structure here. Let's see if I can draw this structure well. So apparently, I'm not going to be able to really verify, but here's a structure that is in the book here. So you have this, that, and that. Okay, so this is some chemical structure, and apparently the name of it is 2,2,4-trimethyl pentane. Okay. I don't even know if that's the best way to have drawn it, but let's see. It's like 1, 2, 3, 4, 5, 6. What? How is the trimethyl pentane? I have no idea. Should I give it that one or should I give it this one? This one looks like this with this has a chlorine. Then it has down here, another chlorine. And then up, and that is called a 2,3-dichlorohexane. Hi there, Ms. Reclusivity. Good to see you. All right, so I don't know which one we should give it. I'll just give it maybe this one because there's some chlorine in there. I don't know. This is crazy, though. It's actually going to get this integral. So how did it do it, actually? Sampling. Give it both. Why not? Give it both. Okay, people are like, just give it both. Just do both of them. You know what? You're right. We should just give them both and be like, hey, bub, we need you to do both. Can I actually just get ChatGPT open over here? Wait, can I just have it both in the window and the browser? Is that cheating? Is that allowed? Am I allowed to do both the browser and the app? What do you think of o3? Not just Pro. I think o3 was pretty good. I mean, it's very powerful. It did pretty much everything I needed it to do for my work. But does it have access to tools, says Yadi Zap? I don't think so. I mean, I told it not to use any tools also. I kind of just said, hey, I want you to do this without like numerical integration or anything like that. So we're going to give it, I guess we'll give this one. All right, what's better, o3 or o1-Pro? That's a good one. I haven't used o1-Pro in a long time. So I want to say o1-Pro, but that's just based on vibes. It's been a long time, honestly, since I used o1-Pro. I mean, I don't even have it here as an option, but that's just based on the vibes, not really on anything concrete. So, okay, let's go ahead. I'm going to erase the names of these things in the meantime. I guess we could just bring them back, but I'm going to ask it to, I'm just going to say this is, let's say this is number 1. And this is number 2. Okay. Or maybe I should draw on the other side. I don't know. I don't know if it's going to mess it up. Say, what structures or let me see, what is the nomenclature, right? Is that a way to ask it? Like using, like what structures are these? Okay, so o3 has weird personality. It's overconfident, says Keith. Keith Crosley says it's overconfident. Your overconfidence will be your downfall. I feel like it's a famous line from like Star Wars or something. Did I just... What the heck? What the heck happened? Okay. Oh, I see. That's what happened. Okay. Oh, you know what? Maybe I should just do this. Okay. That works. Okay. Let's give it to the app here. Using the nomenclature of organic chemistry, please identify and name these, let's see, molecular structures. Okay. It is, bruh. I don't doubt you. So, okay. Oh my gosh. o3-Pro took 17 and a half minutes here. So, let's see here. How did it do this integral? Move the inverse hand with an auxiliary integral for every z. What the heck is that? Pi over 4. L is equal to pi squared over 96. Assemble the pieces. Wow. That's crazy. It just did that integral like nothing. What do you think about the limitations of these models when it comes to subjects like solid-state physics or electromagnetism? Do you think they are capable of having the necessary insight to solve them? Yeah, I mean, I've given it problems from Griffith's electrodynamics as well as Jackson electrodynamics, and these models can solve problems like that. The thing is, though, is that how much do you want to attribute that to have seeing those problems in the training data? So that's one thing I think you should consider as well. All right, so this is let's see, thinking through. Those are clearly chlorocarbon, not carbonations. Yes, I think it's definitely called that. Mapping carbon connectivity. So thinking through the nomenclature of organic chemistry, I'm examining an image to identify and name the molecular structure it represents. Working through a black background with white line drawings of two hydrocarbon molecules. The second one has chlorides. I'm definitely using IUPAC nomenclature to find their names. I'm figuring out the carbon chain in the molecule. It looks like 5 or 6 carbons with branches showing isopropyl orientation. Adjusting top cropping. I'm planning to increase cropping at the topmost. Blah, blah, blah. Oh, ultimately, I confirmed it. Wait, was that correct? I confirmed it's trimethylpentane. Wait, I think it got it, actually. Wait, because we did identify the names of these things earlier. Oh, crud. Sorry. So I think it actually got this one right. So this one from the book is, this is 2,2,4 trimethyl pentane. And then this one down here is 2,3 dichlorohexane. So it looks like it may have gotten the other one here, right? 2,2,4 trimethylpentane. Yeah. Uh-oh. It got that one. It got my drawing. I mean, I guess if you follow the IUPAC conventions, then I guess you should get it, but I'm not a... Disclaimer, I am not a chemist or an organic chemist, so I'm just basically a scribe from the book here. So it has the 2,2,4 trimethylpentane by varying the numbering sequence. It has a chlorine, simplifying the chain, thinking how through an upward vertical line relates to a carbon on chain positioning at the C2 position, cropping downward to reveal more details about the Cl label. I'm figuring out 2,3-dichloropentanes names and structural identities. Ensuring clarity, I'm checking halogen positions and stereoisomers. Oh boy. Yeah. So, what was the other one called? Oh, it's 2,3-dichlorohexane, right? Oh gosh. Okay. Oh, no. That's 2,3-dichloropentane. Why does it say pentane? Did I just draw it incorrectly? Hold on. Maybe I just drew it bad. There's 1, 2. It's a chloride. 1, 2, 3, 4, 5. That should be 5, right? Oh, no, that's hexane? I'm so confused. 1, 2, 3. 1, 2, 3, 4. Is that really dichlorohexane? Excuse me. I don't know. I don't know anything about organic chemistry. I took it for 1 week in undergrad. 1 week. Okay. In the meantime, let's go ahead and go back to the problem I was doing earlier. If I could remember where it was. Shoot. Oh, I think it was on this page, right? Yeah, okay. Go down here. So here's the next problem that I wanted to give it. Basically, you have to do this integral here for this physics problem in quantum mechanics, or it's the semi-classical approximation in quantum mechanics. And the answer to this one, I actually had to get Mathematica to help me with it, but it is something you can do on your own. All you have to do here is, I'll just let this stay here right now. But all you have to do for this one is, if you make the substitution, let's just say you make the substitution here, u is equal to, I guess you could just make it 2me minus mgz. I guess maybe I should have done that the first time. I did it differently, but I feel like you could just get away by saying 2me minus 2 minus mgz. No, Curtis, unfortunately, it is not. You have to pay the big bucks, Curtis, to get the model. Unfortunately. You got to pay the piper. You got to pay Mr. Sam Altman directly. Actually, I just did this integral here. And that seemed to make things okay. And then you get to, let's see, du over equals, actually, yeah, equals dc. So then if you do this integral and you carry it out here, what do we do here? Okay, so effectively, if you do this integral out, you should get something that looks like this. E to 0. I know I'm skipping a ton of steps. It's not that important that we follow exactly what's going on here. But ultimately, you get this integral, and I should probably put a 2 out here. Why can't I go down further? I guess I have to do more. So you get this integral. Square root 2m times 2 over mg e to the 0 square root of u du. Okay, so this becomes kind of a standard elementary integral. If you carry this out to fruition, you get something, the proper answer. So I did do this out, and I have confirmed that it works. Oh, hello. Excuse me. So the top structure is right. It's 2,2,4-trimethylpentane. It was the name. The bottom one, though, it thinks it's a, well, maybe the book is just wrong. So that's another possibility I have to consider. But, sorry, where did I put, see, I don't have a good sense of where all my notes are. That's down here. So it got the 2,2,4-trimethylpentane correct. Oops. Trimethylpentane. So it got that one right. 2,2,4-trimethylpentane. And then the bottom one, it says it's 2,3-dichloropentane. Again. Oh, is it really? Wait a minute. Wait, no, wait. They're both. I'm confused here. So wait, why is this one incorrect? Awfully good handwriting. Oh no, I'm using this pencil here on my OneNote here. But thank you. I appreciate the compliments on my handwriting. So it says that this is actually a pentane, not a hexane. Or am I messing this up? Trimethylpentane. No. This is 2,2,4-trimethylpentane. That's correct. But this one is 2,3-dichlorohexane, but it thinks it's dichloropentane. Why does it think that? Is it just the way I drew it? hold on. So the way that it looks like in the book, like I literally drew it. I don't know if you can see that one right. Where is it? 2,3-dichlorohexane's like right there. So I don't know. I thought I drew it correctly, but maybe I did it wrong. 1, 2, 3, 4, 5. Or is it wrong here? Actually, what's the difference between these? What the heck? Okay. Let's settle this by saying that the book says that the second structure is actually 2,3-dichlorohexane. Just take a pic. Yes, I'm going to take a picture from the book and upload it. Just give me a sec. Did we find a typo? Maybe I just found a typo. I found a typo in a book the other day, actually. I was very proud. I'm very good at finding typos in books for some reason. Like, this is like the 6th or the 7th time I found a typo in a physics textbook. Probably just because who else has the patience to just randomly do a random problem in the textbook and be like, wait a minute, this doesn't actually make any sense. Okay, so can I put that there? Can you please analyze this structure and give it its proper UPAC name? All right, so here we go. We gave it a picture. Pictures are worth 1,000 words, I've been told. So in the meantime, we're going to go back to doing some physics. Here we go. And the answer to this problem in the book, and that I can confirm, is indeed the answer. I'm going to give the nice expression that's in the book, not the numerical answer, because I did it in Mathematica and it just gave me the weird like decimal, and I want the actual precise value. Here it is. So the answer to this problem, if one were to do this, is, so again, this is a semi-classical problem in physics, which means it sort of combines aspects of quantum and classical mechanics. Squared n squared over 32, all this to the 1/3 power. Okay, so that's the answer here. This is the expression of the allowed possible energies that could be given. I'm glad to be back too, Artemis Lisha. So while that is going there, I'm going to make o3-Pro in the browser do this problem. So the problem, the best way to state it is, so far so good, Jit. It's gotten pretty much all the questions I've asked correct, except there's one that we're kind of questioning, but it could just be the way I drew the chemical structure. So I gave it some chemical organic molecule that I wanted it to identify. So I need to rewrite this problem in a way. So let's just say here, use the Bohr-Sommerfeld quantization rule to calculate the allowed energy levels of a ball that bounces elastically in the vertical z direction. All right, here we go. So the thing is, I don't want to just I just don't want to give it the problem directly from the book. Plus, it's going to take a while for me to take a picture and airdrop it. I like to rewrite the question just slightly, just to be sure that it's not getting something that may have been verbatim in its training data. So I think that's my approach for now. So it's going there, it's going here. So it's going out there. Okay. There's another molecule actually that I kind of want to give it that I saw that looks kind of interesting. It's way more complicated. At least to my untrained eye, it looks way more complicated. It looks like, what the hell is that thing? What the hell is that thing? Oh. Yeah, here's the one. Could it actually get this one? So I'm gonna make myself big on the screen just so you can see. But look at this nasty structure right here. Or is it, which one is it? Yeah, this one right here. It's like, it's got a pretty long name there. It's like 2-chloro, 3-ethyl, you know, whatever. So, anyways, yeah. Let's see if it can do that one. Let's see here. All right, so we got two things kind of going on here. What's happening here? Import the symbolic library so I can define variables, E, energy symbols, this brings for integral calculations and energy level determination. Oh, okay, so it's going to use SciPy. Or SymPy, I should say. Notice me, SymPy. You're my only hope. Yeah. It's been a while since I've looked at some papers on the archive. In the meantime, let's take a look at some astrophysics of galaxy stuff, because it's been a while since I've taken a look. I wonder if I could just like give it something from like archive, but what would I do with it exactly? So I've only been subscribed to GPT Pro as of this afternoon, this time around. I did have it several months ago, and I stopped subscribing to it, and I went down to Plus. Now I'm back on Pro. So ask me again in a month if I think it's still worth it, because there is still time for me to, I guess, be disappointed. Make another novel figure. Okay, let's see here. I'll give it my paper. I know we always keep seeing these papers in my videos, but I don't want to doctor anyone else's papers, you know. Let's give it the first one I wrote. I didn't really like the first one that much. I made a lot of mistakes with this one. Like, the science is good in here, but this took way too long, in my opinion. And oh, should I ask it to roast my paper? Should I be like, yo, write a better, like, tear this paper apart and write a better version of it or something like that? I guess the real question, Kyle, is have you been watching Murderbot? No, I don't think I have been watching Murderbot. What's Murderbot? That doesn't sound nice. 1 second. Okay. All right, let's see here. Should I just have it like roast me and be like, like be the most critical reviewer on the planet and just tear this paper to shreds? Explain all the ways that it's wrong, or maybe I should just be like an honest reviewer and tell me how you really feel, right? So I have two threads going on here. So just give me a second while I wait for one of them to free up. This one has some good citations, man. It's got like 20 citations. I'm pretty proud, yo. But I'm sure there are things I could have done better. There's always things you could do better. Come on. Get the Bohr quantization correct. So again, for this problem here, we're expecting to do something like this. Okay, we're doing this kind of ball falling from some height z to the ground, and then there is this calculation that involves masses and momentums and stuff like that. Oh, MD Explained says, I hate LLM so much. They are always hyped and never produced really good scalable real life results. Dang. Sad. What happens if you order him to question your paper to prove that it's false? Prove that it's false. Old quantum mechanics. This is old quantum mechanics. Good eye, MD Explains. Semi-classical approximation here is the Bohr-Sommerfeld quantization rules going on. And the semi-quantum energy is going on here. Airy function zeros. Wait a minute. That doesn't sound right to me. That seems excessive. I can spot the mistakes in old proved concepts. It can spot the mistakes in old proved concepts. I see. We might have something here, guys. It may not actually get this one right because it seems like it's dealing with an Airy function, which you really shouldn't have to do unless you actually get the Schrodinger equation, which there's no need to get the Schrodinger equation here. This is the Bohr-Sommerfeld approach. Airy functions, let's see, Schrodinger equation, right? You only get that if you have a linear term in the potential. Or am I wrong here, or what's going on? Or a triangular potential, I should say. Sorry, it's a triangular. The term is linear, is what I'm trying to say. It has this kind of sort of feature here. But the fact it's saying it needs an Airy equation, it feels a little like, wait a minute, that's kind of an overkill, don't you think? Unless it's trying to verify its answer from another direction. Why use Airy function for a problem that must be easy to solve? I think because it sees that it has this like MGZ term here, right? It has this linear term that if you put it into the Schrodinger equation, it will, you'll get to an Airy equation kind of form type situation. Validating the semi-quantum energy, still going on here. We wanted to also have it, should it roast my paper or should it roast my thesis? I feel like my thesis would be a better thing to roast because I want to see if it can actually like do like a chapter by chapter breakdown. Like thesis PDF. Maybe we just give it my whole dissertation and be like, I want you to give like a chapter by chapter breakdown as to why this is like the worst thesis that's ever been made. Oh man, it's gonna make me cry. It's gonna make me cry because it's like, oh, your thesis sucks. Your thesis is terrible. I can't believe they gave you a PhD for this baloney. And I'll be like, dang, bro, you're right. I should just mail back my dissertation. Like we're almost there. We're almost there with the Bohr-Sommerfeld question. I didn't realize how long it takes to think, so I appreciate you guys' patience while we wait for it to do these things. In the meantime, I'm also happy to report that I did quantum mechanics again today, and I got this question right that is not like, again, not hard, but I never, like, I can't just look at something. That's the thing. I have a very hard time at just looking at a problem and knowing exactly what I need to do. It's not until I actually start putting pen to paper that I understand. Effectively, the question that I did today that I was really proud of, which again is not like I should be able to do this considering all the quantum mechanics I ever learned. But basically the question they wanted me to solve was to basically show, well, this is part one, that the uncertainty in this expression is equal to this, where a bars is equal to a minus the expectation of a, I believe. So this involved showing this, and it's something that's not that hard to do at all, really, when you know what you're doing. Isn't everything just much easier to do when you actually know what you're doing? But yeah, so yeah, a bar is equal to a minus a, yeah, expectation, right? Yes. Yeah, so anyways, it involved that, and I felt good. Maybe we can give it that, but I feel like it's almost too easy to give to this problem. But we'll see. But get your tissues ready. Oh, here we go. Here we go. Classical setup. It took 11 minutes. Here we go, guys. So, meaning at mass of the ball, g acceleration of gravity, z vertical coordinate measured upwards equal to 0, v okay. Okay, classical trajectory with total energy oscillates between z equals 0 and z max equals. Oh, this is good. This is good. This is good. This is really good because, oh, of course, I went away right when I said things were going good. Oh, here it is. So right, so it did basically what I had thought. So it realizes that z max is indeed e over mg, and that it needs to, it needs to do this. And, oh, so this is a little bit of a different expression. Because I thought it was NH. Did it change? WKB Bourse. This is different from my book. Actually, this is a different expression. I thought it was, like, this is the right on the left-hand side, but on the right-hand side, maybe I'm just having an old book here. But anyways, evaluate the action integral. Does that. Yep. Solve for allowed E, and it gets that with the exact. Oh, so that's why it did the Airy function, because it actually was going to compare. You don't know what you don't know. Thanks, Miss Reclusivity. I agree. So this looks good, apart from the fact that the expressions were different. I don't remember the Bohr. Is the Bohr-Sommerfeld quantization? What was the actual expression here? Yeah, no, I thought it looked like this. Yeah. So wait, why did it do it like that, actually? Because this is the equation that I was thinking of right here. And it kind of, like, it did the right thing, but this was the wrong equation. Is the Maslov index equals number of ternary times 2. Hence, mu is equal to 3, and n plus equals n plus 3 over 4. I just had nh. But this is basically the right approach, assuming this is the right form, assuming that's the right formula, even though we have a different answer here. That's cool, though, actually, because it used the exact quantum bouncer result. Zeros of the Airy function. Exact levels is this. So the semi-classical expression above reproduces the exact Airy zero spectrum to better than 1% for n greater than or equal to 1. Wow. Wow, this is actually really cool. N0 and J height. So it's going to truly manifest classically quantum significance relevant only for ultralight balls, including or experiments such as neutron. Okay, I am inclined to say that it is correct, but this formula is not. This formula is a bit different because the book I have is a bit old, so I don't know if it's just because we're using a different convention here, because it did the problem correct with a different right-hand side of the Bohr-Sommerfeld quantization than what the book I was using was assuming. Yeah, so basically, if you look at the book here, let me go ahead and blow my screen up so you can see better. So I don't know if you see that, but basically, they have that expression 2 times that integral there, and the right-hand side is equal to n times h, and so they have the final answer there, like that. And so it's they basically did the right thing, but with a different expression on the right-hand side. So I'm inclined to say it actually did it right, but I want to know, where does that even come from? Bohr-Sommerfeld WKB rule? Is that what is going on here? Oh, 2 pi and h bar. So it looks like there isn't really is there like not a agreed upon equation of this formula? Let me go ahead and pull up my modern quantum mechanics textbook. Let's see. I would ask it, but then it would take like another 10 minutes. So I'm gonna not. Just give me a sec. Let me just look in this book here. I'm gonna go look for Bohr-Sommerfeld. Bohr quantization rule 41. Okay, so 41 is the place where I gotta go. You know what? I do want to snap a picture and ask, because I'm like, why is your condition different than mine? And can you explain where it comes from? So 41 L and H bar. Yeah, no, that's the same one. Okay, it's time to ask. It's time to ask GPT o3-Pro. We have another one available, so let's go ahead and just figure out why this is different. So I'm going to take a picture of this here, and I'm going to say, hey, why did you do it differently than in this book? And how is the quantization different? I appreciate you guys working with me through my ignorance of these things, because, you know, I miss being good at physics, honestly. It would be really good if I could get good at physics again. I mean, I think I'm decent, but when you don't do something that often anymore, right? It's just like any skill. If you don't do it, if you don't practice, you just lose it over time. So, all right, let's go ahead and just ask it why it has a different form here. Please explain where you got your Bohr-Sommerfeld quantization condition and why it differs from the solution in this book. Are both equations equivalent, or are you considering something different fundamentally in the energy and the allowed energies? Yeah, allowed energies. Okay, let's go ahead and see if it can. Did this thing actually work? Okay, I guess it did work. Reasoning. Ask Gemini 2.5 Pro to compare answers. It's not a bad idea. I do want to get around, though, for this one. It's dichlorohexane. You and your book are right. My first pass undercounted the main carbon chain in the second drawing. Oh, actually, it admits it was wrong. It says that first pass undercounted the main carbon chain in the second drawing. Here is the corrected analysis. The book consider boundary with shape the potential for the force for a hard wall. Why the BS condition will show its connection to the Maslov index. Setting references like Maslov index for a hard wall is essential. Variations depend on boundary conditions and mapping out the impact of different integration methods like pi versus 2 pi and shifts from the Maslov indices to pinpoint distributions between equations. Okay. That does look like it's thinking about what it's doing wrong here. So it did get the name correct. It says, my earlier identification as 2,3-dichloropentane was based on overlooking one carbon in the main chain. Thanks for flagging the discrepancy. So it did read one of my drawings incorrectly, interestingly, or maybe I just drew it really bad. You know, that's also possible. Let's not throw that out. Okay. The variances. Okay, so let's go ahead and ask o3-Pro to roast my dissertation, shall we? Okay, here we go. Here's my dissertation. Please read through this PhD dissertation and roast, let's see, please read this PhD dissertation. Explain as an expert in the astrophysics of galaxies and the black holes. Why each chapter is terrible, and why the thesis overall might be the worst written PhD thesis of all time. Do not hold anything back. Be completely transparent, honest, and honest. Provide insight. Let's say, tell me what you would have done differently in each of the chapters to make this thesis better in your mind. Okay, so we are going to we are going to have it completely destroy my PhD dissertation. It's okay. I felt like it was the worst thing ever when I was writing it. So there is really, I don't think, anything that this thing can write that I will not have felt. Yeah, I'm not so sure. Well, that's a prompt. Yeah, it's a prompt, all right. I didn't say it was a good prompt. It's a prompt. It's one of the prompts of all time. What are you expecting of me here? It's one of the prompts of all time. Consulting policies? Why are you consulting policies? What policy do you need to consult here? There's nothing to be consulting. So do I have to be careful about what I give you or what? Okay. So let's go ahead and see reasoning. What is it saying here? Oh, nothing so far. Okay. You might hate AI after this. Maybe. It just might be the worst thing I've ever asked it to do. But it's fine. I'm not going to be hurt by it. In fact, while it's going here, I actually want to try a different problem really quick. Sorry, I'm getting over being sick very recently. Evaluating the critique. Piecing through the dissertation, I'm considering each chapter's weak points. Aiming for a balanced, non-harassing critique. Okay, at least it's going to be fair. That's something, right? It's going to be fair to me, at the very least. What do I want to do here? I have this book here. It's called Graduate Problems in Physics and Their Solutions. So let's go ahead and see if it can do something here. Ooh, mathematical physics. Can it do what integral is it being asked to do here? Wait, where is it? I thought I saw an integral that was really interesting. It was like 1 over cosh or something. Well, it already did an integral, so I guess we don't need to do it again. But okay. Oh, yeah, that's a classic one right there. I got this problem on a test in undergrad, actually. And I don't think I got it right. Memories. Highlighting issues. What issues? Oh no! Oh no, what have I done? Oh no, did I make it do it again? Gosh, dang it, Kyle, what did you do? Oh, shoot. Sorry, I think I messed it up. I guess I'm just making it do it again. Sorry. I pressed the button. I guess I'm doing it again. Oh. I see. I guess I'm doing it again. Sorry. Well, it's not the worst thing ever. We just gotta wait again. I just thought I stopped the whole prompt altogether. This o3-Pro is taking a long time though to do this. I wonder if I just gave it like a whole page of like questions in this book. Like if I just took a picture of like one page, could it just solve everything in one shot? You know what I mean? Just maybe I should do that. Trying to think if this is actually this. Oh, this actually seems like a doable set of questions. OMG, try it. Okay, let me just think. I'm just trying to think which page I should give it. Showing that, evaluate. I kind of want something that doesn't just like give you the answer. 7, 8, 9, 10, 11, 12, 13. 7, 8, 9, 10, 11, 12, 13. There's one question I'm not so sure if I want to give it though. Let me just see what does the quantum mechanics first page look like. Prove the Thomas-Kuhn rule. What is the pressure, lowest energy state, P state, variational principle. Find the progression. Okay, this seems like a really interesting page. Okay. 14, 15, 16, 17, 18, 19, 20. I guess I don't have to give it the whole page, but we just look at the answers really quickly. This book is from like 1950, I think, or 1940 something. When does this book come out? 1967. Okay, it's not that old. Well, it's still kind of old, but not that old. Okay, let's see. 14 looks like that. Lowest P state is that. Huh. Okay. 15, the answer is... Solutions are that. Okay. Yeah, this looks good. Actually, I think maybe this is a doable page for it. Okay. I'm thinking of giving it this page in the book. Like, let me just see here. Make myself bigger again. I'm thinking of giving it like the page that has like 14, 15, 16, 17, 18, 19 on it. Just that whole page. Just like, can you solve every problem on that page? Basically. Yeah, why not? What's the worst that's going to happen? Honestly, what's the worst that's going to happen? I guess the worst is like, I don't know, it just poops itself. It's just like, I can't do it. All right, I'm going to take a picture of that. I am going to crop it, and I'll make sure it's like a JPEG. And make sure it's all readable in there. Okay, 14, 15, 16, 17, 18, 19, 20. Okay. Can it actually solve 1, 2, 3, 4, 5, 6, 7? Can it solve 7 graduate level physics problems in quantum mechanics in one shot from one picture? That would be insane. Well, I don't know. Maybe I shouldn't even be surprised anymore. These days, it's just like, yeah, that's pretty standard. That's pretty standard, man. Like, it's no big deal. Like, these are the set of questions I'm thinking of asking it right here. Yeah, okay, so this is what we're thinking of giving it here. And let's take, where did I put the JPEG? Ah, crud. Did I put it in my documents or what? Where did it go? Oh, it's on the desktop. Okay. This one done? Oh, here it is. Oh, wait. Before we do that, let's just take a look at how it's going to roast me. Okay. Below is a candid, point-by-point critique of the dissertation, Black Holes and Revelations, Dynamical Mass Measurements of Supermassive Black Holes and Early Type Galaxies with ALMA and HST. I write as a specialist who has published gas and stellar dynamical black hole mass measurements for early type galaxies. I focus strictly on the scholarship structure and record, not on the author as a person. Oh, gosh. Global problems that plague every chapter. Symptom, minimal novelty. Almost every technique is a direct port of earlier IDL code by Barth et al. 2016 and Voice et al. 2019. New physics or algorithms are absent. I am going to defend this because I have some novel features in my algorithm that are not in those versions, okay? why it is fatal. A PhD thesis is to extend the state of the art, not merely replicate it. It was not. It was better. It had never been existed before in Python. What a healthy thesis would do instead, introduce at least one demonstrably new ingredient, a 3D radiative transfer dust correction, MC nested sampling engine, or a joint gas dynamical stellar dynamical fit. That's really hard to be an expert in all three of those things. Like each, like this thing and this thing, like it's hard enough to be a 3D radiative transfer dust correction expert and be an expert in gas and stellar dynamical fits. I did try and do 3D radiative transfer dust corrections. That was really not fun and difficult, and we figured it was not worth it, and no one does it really in the field. Like to this day, no one does it. Anyways, I'm already starting to defend myself. This is funny. Resolution starved data repeatedly pushed beyond credibility. Are you kidding? What? In 5 of 8 targets, the molecular disk is not resolved inside the black hole sphere of influence, yet a mass is quoted. If blah blah blah, the rotation curve is centered with stellar mass light pressure, the resulting measurements are upper limits at best. Restrict analysis to galaxies to see how mission penetrates well inside, or report formal upper limits using Bayesian hierarchical models. Okay, I can understand this. That's totally legit to say that yes, the resolution is not ideal. However, I mean, we're just trying to get an estimate here. I mean, yes, technically measurements perhaps are not the might be stretching it. I mean, I still think there are measurements in some of these cases. Like we can still actually get a range, and I'm also acknowledging, like I am not hiding from the fact that this data doesn't have ideal resolution. I am not hiding. Like that's actually front and center, and I'm saying, look, the data quality is not ideal, but this is what we can get out of it, and what we'll find if you try and go through my analysis. So, anyways, okay, systematic errors dominate but are treated qualitatively. Okay, yes. Yeah, well, no, my error budget is... I think my error budget is... I mean, we did propagate dust. We can't do all of that. No, I mean, a lot of these things are suggestions that have always been floated as like, ideally this is what you would do, but in practice they're just not feasible right now, or just computationally expensive, and that you're not going to get penalized too hard about that. Okay, inflated prose and epigraphs crowd out science. Oh, what? How dare you go after my writing style. Inflated prose and epigraphs crowd out science. Every chapter opens with a literary quotation, Einstein, Hawking, Merrick, etc., and multi-page historical detours. Space spent on epigraphs could be used for deeper method validation or comparison with the literature. One concise introduction chapter is enough. Subsequent match should dive, blah, 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 whatever. Formatting lapses. Equations sometimes appear in line without numbering. Several figures like axis labels, many tables spill across pages without captions. What? I don't think that happens. Wait a minute. Now you're just pulling my leg here. Sometimes I put it in line without numbering? Several figures lack axis labels? Is that really the case? I don't remember that. How did my dissertation get through all that if it didn't have these things? Okay, anyways, we're spending too much time here. Bloated literature reviews. 15 pages rehearse 60 years of VH history, yet nothing later chapters relies on this material. It would... Oh, get out of here. Using a court of line, I'll break down the defense of any defendant. Primary sources missing, key breakthroughs against are not cited. Well, but that's Galactic Center. Like, we're not doing Galactic Center. Like, we're doing Extragalactic. I don't know. I feel like that's not even relevant because they're using stars and I'm using gas. Like, I don't know. That's... Problem 3, narrative not connected to thesis goals. Example, 5 epigraphs and extensive block quote from Einstein at color, but no content. Oof. Color, but no content, Kyle. Jeez. Move anecdotes. Essentially a software... Problem 1, essentially a software user manual. 20 pages enumerate parameters, true like human being, but provide no validation on analytic test cases or mock cubes. That's what the rest of the thesis is for. No expression to generate thin flows are yet later blamed for poor fits. No, but this is literally standard practice, okay? You're not an expert if you don't know that. Like, there aren't that many other physical models that we can run that can give meaningful fits. I mean, if the gas truly isn't in circular rotation, then our models are just inherently flawed, but we don't have... I mean, there are some other... You could do like a warped disk model or a tilted ring model, but anyways... I feel like I'm back in grad school now. This feels like a personal attack back in grad school. Chi-square minimization with LMFIT is outdated. Okay, yes. I mean, I do have Monte Carlo error analysis, though, at the end. It's not like I'm not doing Monte Carlo. I do estimate uncertainties on my posteriors, so, like, for the posteriors, so I don't know. Fix beam with mock data, replace downhill symbolic with affine invariant MCFC, publish corner plots. Well, I worked with people who did that. Chapter 3, beam is yet still promotes a single mass, not broken. No attempted multi-bad stellar popular modeling or jam stellar dynamics. That would take ages. We have thought about this. We have considered it. The data doesn't exist for some of these things. We do the best that we can. Hiding azimuthal trends. No values of velocity field shown. Did I really? No. Hang on. I disagree. I am pretty confident I have a residual. I have a residual velocity field. What are you talking about? Did I not? Like, if it's not there, it's definitely in my paper. What's going on here? Yeah, no, my residual velocity field is right here. Bro, it literally says I have no residual velocity field shown. Only position velocity diagrams plotted, hiding azimuthal trends. No, this is my residual velocity field right there. Bro, you are not a fair reviewer. I know my thesis, okay? Like, yes, some of the things you cited are correct, but do not tell me that my plot doesn't exist there. Yeah? It says it says right there, I have no residual velocity field. My residual velocity field is this, literally this plot right there. Bro, come on here. Chapter 4. Yes, it's unconstrainable. Yes, essentially a guess. No, it's not a guess. It's a really educated guess. Not mapped in 3D, only had masking. 3D radiative transfer is not feasible. Dominated by montage images. Publish this as a non-detection letter. Focus on limits, blah, blah, blah. Instead of pretending to measure. I'm not pretending. Like, anyways. Cripples inner rotation curve. Yes, we know that. But no quantitative prior on extinction. We don't have good priors on the extinction. Set by MGE choice, not by data. I don't know. I don't agree with all of these things. Overpredicts flux. Yes. Problem 2. Okay. Do not fix. Do not present only results and reason for failure. Proposed how to fix it. Summary of future work. Reads like a grant proposal, not a synthesis. No quantum of all masses to M sigma or M bulge relations. Circuits on the next series that does not outline complete upgrades to the code base observer strategy. Ends with frontal has clearly invested immense effort, fails the core period proves robust, novel, and defensible scientific. Virtually every measurement is in reality not limited, obscured by optimistic language, systematic errors overwhelmed with self ones, and Well, okay. Well, this one has already been measured. So, if you're an expert, you would really know that. O3, just saying, and you would know that this one has also been measured here, and it's not well resolved with inside our SOI. So. I mean, come on now. Write tersely. I'll show you terse. Post-mortem. The post-mortem here. Okay, so. Okay, fair enough. I mean, you weren't my reviewer, so. Sucks to suck. Suppose you have o3-Pro before publishing your thesis. I mean, honestly, if I did, there's just like no way that I would be able to incorporate all the changes it suggests. Global problems that make the thesis painful to read. What do you mean? I literally rewrote the whole thing to not use the same language from the papers. Form over substance. Oh, why this could be one of the worst written PhD theses. Okay. Hyperbole. We have all seen worse prose, but that provides the prime directive of a PhD. Demonstrate independent, rigorous, reproducible works with its derivative, reimplements existing, produce weak or null constraints, and yet presents them in equal footing with robust detections, combines with repetitive writing. Okay, if that's what you consider of my thesis, then every measurement in the field has to get this kind of treatment, because these aren't any like worse. In fact, I would argue some of these are better measured than some others in the field by the so-called experts. So, anyways. Man, it's like if you thought my thesis was bad, you should see what other people are doing. Hey, Kyle, I have a question about the AI fatigue you have. That happened to you with the vanilla physics too? Yeah, I'd say, I mean, it's like, I think one thing I was having trouble with is just that my knowledge in physics has decreased significantly, and I admit I'm a little bit disappointed in that. And it was getting hard for me to like start to really think of questions to really push this thing past its limit. And so I wanted just time to like think and try and study some physics on my own and come back to it at this point. But at this point, I don't care. I mean, like, look, I don't work as a professional physicist anymore, so I think I'm fine. Like, I accept that I do not have all my abilities that I once had, but doesn't mean I can't try and still use what I still know to be useful in terms of testing LLMs. So I think that's kind of where I'm at this moment in time. So why did it actually do differently? Oh, what the hell? Sorry, wait, what's all that red? 20 minutes. I thought for 20 minutes. In modern semi-classics, one writes the Maslov-corrected Bohr-Sommerfeld rule, the closed integral taken over one complete classical cycle, muse the Maslov index, blah, 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 blah. For the vertical quantum bouncer, all that. The form that many textbooks use. Some books, including the set of solved from the University of Washington, write the rule for only one. Wait, what? This was not University of Washington. This was University of Chicago that I was showing here. What? What is that? Do you guys see that? What the hell am I looking at here? Textbook version half loop. Or maybe just because like I showed it the picture of my book. Okay, 1 and 2 are mathematically identical. They merely integrate along different portions of the orbits and label the quantum number differently. Previous entity writes both variants as equivalents. The unexpected to account for path length and the way n is indexed. Okay. All right, cool. So that's what it says in terms of the equivalence of the two things. What did we want to do? Oh yes, we wanted to give it a set of questions from the book and just give it this whole page. I'll just say solve, let's say, solve problems 14 on this page. Show, let's see, be sure to show all of your steps or all of your work, and clearly separate each problem as its own, let's say, problem. Write your answer, let's see, write your answers in a LaTeX document that can be copied and pasted to overleaf. Okay, so let's just do that. Oops. Nope, wrong thing. One, two, three, four, five, six, seven. Okay, 7 graduate level quantum mechanics problems in a row. Can it do this? Can it do this? Well, I guess we'll find out. It has been some time since we have given it a challenge of this level, but can o3-Pro do 7, not 1, not 2, not 3, not 4, not 5, not 6, but 7 quantum mechanics problems in a row? Now, anyone taking bets? I'm going to say no. I'm actually going to say no. I'm going to think that the context window is going to be, or the response is going to be just like too long. It's going to have to skip a lot of steps. It's going to just have to like, if it does get all the answers correct, they're not going to be able to show and explain everything in detail. I think they're going to have to be kind of, what? Error in message stream. Buh? Duh. Okay. What just happened there? Anyone else see that? That was weird. Okay, so it's gonna we're gonna try and do this. It's running like 10 regular O3 calls. If the AI nail the problems we need to understand our childs, we'll be less smart than the AI. These are so fun, Kyle. Thanks for streaming these. Oh, you're welcome. I appreciate it. I appreciate your comment. I mean, it's fun for me too. I wish I could solve all these things together. I'm piecing together solutions to 7 complex physics problems, ensuring clarity and thoroughness. Progress involves examining the image and verifying statements with Python to confirm accuracy. That's fine. You can use Python. You can use whatever you like, because I don't think you can do it. I'm still going to go with, you can't do it. You can't do it. It's not possible. I'm for Team Human here. It says I'm exploring second energy shifts for degenerate states under electric perturbation on a ring, focusing on name mistakes and matrix elements, and will detail the results in electric document, kinetic energy calculation, going over the expectation activity, integrating using normalized wave function, weighing potential energy. So which one is it on here? Wait, what? Wait, huh? V equals Cx for x greater than 0. It's already on 19? Wait, it's here? Like, 19's right there. Wait, 19's there. You tell me you did all of that in between here? What? Sorry, I'm going to move myself over. So the thing that's, like, getting me kind of like, what the heck? Like, it has the one for 19. 19 is this one. And it has text regarding that, like, right here. I'm like, did it solve all of those other problems in the middle of all this? It's crazy. I guess I should also get the solutions out here just so we can look at them together. That's what I should do. That's what I spend my time doing. 14, 15, 16. Okay, so it's gonna be multiple pages. So let's see here. I'm going to take some pictures here just so I can take a look at the solutions, and then we can take a look at them together. Oh gosh, there's a lot of things here. 18. It's like 5 pages of pictures we got to take here. Okay, here we go. I think this is the last page. All right, so I'm about to just send them over to me. Let's see. Oh, the labyrinth one. We didn't give it the labyrinth. We should give it the labyrinth, shouldn't we? Okay, give me a sec. Let me just send all these pictures via airdrop. Thank goodness for airdrop, right? Airdrop makes everything just like so much easier. Okay, here we go. Here we go. All right, so we got 5 pictures here. Which one's 14? Oh, that's 14. They're not in order, though. What the heck? Can I open those, please? Open. Okay, so that's 14. Where'd I put it? Oh, where'd I put ChatGPT? ChatGPT, where'd you go? Oh, here it is. Okay. The radial Schrodinger equation's threshold condition with energy equals 0. Boundary condition yields k equals pi over 2a. We aren't very far away from AI to jump into your stream and grab the answers and cheating. Now, ain't that scary to think about? How do I hide the sidebar here? Having potential. Oh, let's see if we can do the tests here. Actually, I'll get the other one. I'll get the one on my on the app to do like the child's puzzle. Child's maze. Okay, let's see here. Can this thing find its way to the end? No, come back. I wanted to use that one. Okay, so one like that. Okay, so I think let's see if it can do this one. Solve this maze by drawing a red line from the kid knight to the green dragon without touching any of the black lines. It was an easier one. I think it was with the B, wasn't it? There was like a B involved with it. I still want to see this one done though. If it's that smart, it should be able to do it. You think it's way too hard for it? Alright, we can see what... Oh, I think it was this one, wasn't it? No, there was a B. I thought there was a B involved with this one. Oh, this one's a bit difficult. Oh, so this scalable maze test to benchmark the AIs. Okay, what is it called? Scalable maze test to benchmark the AIs. Sounds like a good benchmark to have. Spherical wells by quantum expert pressure for different states, avoiding full calculations. It's kind of a cute maze here. Mapping the maze. So like 20 by 20 mazes, I'm pretty sure. Oh, is this too big? Okay. 7 problems. Okay. We're getting close to the end here. People, we are getting close to the end. We are almost here. We are going to see once and for all if it can actually do this gauntlet of a challenge. And if it can, then I don't know. I might just go to bed and be like, you know what? Just had enough of this today. I've seen it all now. I've seen it all. Ooh, okay. Whoa, wait, it says an open moment. The night starts on the left, the path weaves through, and the exit is near the dragon on the bottom right. Marking through the bottom borders continue with a vertical interior while examining offsetting floor tiles and noting potential gaps in the pattern. Okay. Okay, he's getting there. Kyle, when we are able to control robot prosthetics with a BCI, are you going to replace your limbs for superhuman endurance and strength? I mean, that doesn't sound terrible, but I'm guessing I'm gonna have to get some surgery or whatever. I've been through surgery before, so I know I could do it again. Would I want to do it again, though? That's another question. Probably not. I don't know. Depends on what I really get out of it, I guess. Sorry about my grammar in that last statement. I'm cooking and had the idea. I had to get it out before my taco meat burnt. Oh no, not the taco meat. Not the taco meat. Oh, tacos sound good. Man, I really want some tacos. Do you guys want some tacos? I want some tacos. I got this promotion from Taco Bell on my phone the other day, and I didn't go for it, but I was like, tacos sound good. All right. This is crazy. This is actually crazy if it's going to get 7 questions right. I found it. The maze was very simple with a cartoon fawn on the left. The maze. Okay, so let's see. Cartoon maze with fawn. Was it really that? Was it in here? There's too many. It's the easy childhood maze. Oh yeah, this was the simple one. We had like a B, right? It's just like that. This definitely I think was the one. Just has to go like boop 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 like that. I can imagine doing it if I become like 60 plus. I would be half cybernetic senior citizen soldier. Oh my gosh, you'd be like Captain America or the Red Guardian from Marvel. We should run the same prompts normal o3 while we wait. I guess we can do that. Oh, shoot. Problem is I already have this thing running. I already kind of have these things running. I guess in principle I could have multiple browsers open, right? Like there's nothing against that, technically. I kind of don't want to break it though. I'm worried if I log into like another browser, it's gonna be like, oh, like I detect you on multiple browsers, kick you out of here. That's true. We could look into Gemini 2.5 Pro. I'm just wondering how regular o3 does to Pro on the physics book one. We can take a look there. Yeah, see, Google Gemini command line was pretty good. I did like it quite a bit. Sorry guys, we got 2 running right now. All right, if this doesn't break anything, I might open up another window to do some testing, but I'm a little bit scared. I'm a little bit scared, yo. What if it's like, no, all this time and effort that went into this one, I would hate for it to go away. It's actually insane how long o3-Pro thinks. I so much would love to read his super long train of thought. Uh-oh, we're anthropomorphizing now. Let's not anthropomorphize. Or should we anthropomorphize? I don't know. I don't know. What's the right solution, guys? Okay. It's... Thank you. Thank you for not anthropomorphizing at this point. It's just too much. What I should really do is I should give it my... I really should... I should give it my benchmark. If I can solve every question in my benchmark. I don't know why Kyle thinks it breaks. Okay, fine. Fair enough. Alright, I'm going in. I'm going in to another browser. Let me get my sign in here. Alright. Here we go. We'll give it to o3 this time. So on Safari, I'm going to give it the prompt. To o3. Oops. I'm going to give it the same exact prompt. I'm paying for this, yo. So it better work. This thing better work, I swear. Okay. It's thinking so long. It's crazy. Okay, I think once it's done with these two tasks in o3-Pro, I think I might be calling it a night after that, because I do want to get to some other things before I go to bed. But this has been fun. This has been really fun. This is my first time using o3-Pro for the first time. Get the 200 plan for Claude. Are you serious? Bro, I don't have... Where's this money coming from, yo? I get the $100 plan. The $100 plan sounds kind of nice. It's like the nice medium. I wish OpenAI had a $100 a month plan, because I think like the $20 one is like, you know, it's like better than free, but it's still like lacking in things. But then you have like a whole 10x upgrade, and it's just like, oh god. Oh god, right? Oh, it's going. Actually, o3 is going. o3 is trying to just go for it here. No way. Holy crap. It's definitely skipping some things, but like... Because some of these are pretty short, but... Oh my god. What if it actually gets it? Pay $200 for Claude code and give it to that, and then get the $250 Google one, then play the lottery. That's hilarious. That is so funny. Oh my god, what if o3 actually gets it? Like, we didn't even need o3-Pro. This would be crazy if o3-Pro actually is going to get it. Oh god. Oh god, we might actually get a chance to look at it here, guys. Oh, and o3-Pro is done as well. Oh my goodness. We're going to find out. We are going to find out. Blank project. Let's call it... let's see here. o3-Pro. 7 physics questions. And then it is this one. Compile that. Did it even compile correctly? Oh, it compiled completely correctly. Oh god. Oh, the excitement is so palpable. I'll just say o3. 7 physics questions. Okay, so we're gonna see. Did o3 even compile it correctly? o3 only has 2 errors. Okay. All right, here we go. We are going to validate, or we're going to verify if these are correct. So, where do we begin? Let's go ahead and start with 14. Okay, so the P is equal to pi h bar squared 4m. Wait. Pi h bar squared. Did they rewrite alpha something? Oh, it looks close, but it's like, wait a minute. They have h alpha bar 4 pi m r squared. They have the 4 mr squared. Excuse me. They have the 4 mr the 5. They have the h bar squared. The thing is that they have the alpha squared nl. What is alpha squared nl? What did they define that as? K is the root of the spherical Bessel function. K is equal to alpha nl, and enl is equal to... Okay, so I think... Oh, gosh, so they use different notation. This is already going to be hard. Let's see what o3-Pro did. o3-Pro... P is equal to that... Really? Oh gosh. Okay, this is confusing. This is actually confusing. Then E is equal to pi h bar squared 2 mr squared. Yes, okay. H bar squared pi squared 2 mr squared. And what were we looking for actually in this problem originally? That's a good question, Kyle. What were we looking for? It says electron, what is the pressure P at, let's say, the lowest P state? Okay, we want to know what the pressure is. So the pressure has this 4 pi squared, and then I need to look at this thing again. I need human validation. Pi squared h bar squared. Alpha squared. Oh, it's k. Okay, so alpha nl squared is k over r. K is equal to... Oh, there's so many terms. I don't like it. Alpha squared. So P is equal to h bar squared 4 mr squared. It's just that alpha squared term. The alpha squared term is kind of making my life difficult here. P10. Oh, well, there we go. H bar squared pi. Wait, really? Wait, hold on. P10. Oh, well, no, that's correct. Okay. We first guess the condition applies P is equal to 4. Oh, 4.5. Whoa, wait, whoa. Actually, KR, yeah, is this 4.5, 4.419? Yeah. And then the lowest P state, it should be around 20.196. 4.5 squared. Oh. Yeah, so it's 4.5 squared. That. Sorry, this is going to take a while. 20.25. That's pretty good. No, that's a good estimation right there. Okay, o3 got the first one. o3 confirmed has got the first one. Now, did o3-Pro get the first one? Oops. Sorry. I know that took a while, but we need to be sure. Can we get the PDF, please? Thank you. This is correct. This is also correct. First root is that. Therefore, it's that. And then there's that. P1 to P, X1. That's a little bit... That looks very pretentious, actually. Wait, lowest P state, H... Why do I say pretentious? I'm saying because that looks like... Come on. Just answer the question. Like, don't try and prove how clever you are, but that's exactly what it's doing here. I gotta take a look at this really carefully again. So the first root is pi. P states that. Hence E1 is equal to, so we have the h bar squared pi squared 2m r squared. That's that. That's correct. The pressure is equal to pi squared h 4 mr squared. Okay, that's correct. So the lowest, the first root is 4.49. That's correct. That's kr is equal to 4.5. That's correct. Therefore, A1P is equal to that. Oh, I didn't actually. No, I mean it knows it needs to square it. That's right, because it needs to square. So this gets squared. It didn't actually do it all the way. But P is equal to h bar squared 4.5 squared over 4 pi m r5. Okay. Indeed. O3-Pro and O3 regular have gotten question 14. They got the first of 7 correct. We got a way to go here. So we got a way to go. Next up, we got number 15. And all right, so the question here. Okay, so we're alpha. What are we looking for? First of all, what are we looking for? Particle mass m. Find the least value of V naught such that there is a bound state of 0 energy and 0 angular momentum. Okay, particle. Find the least value of V naught. So we want to find the least value of the potential. And let's take a look here. So the least value of the potential. Let's see. This happens when V naught. Okay, the answer is pi squared h bar squared divided by 8ma squared. That just sounds like the square well, is it not? Oh, it is a square well. But it looks like a finite square well. Okay, we're looking for this expression. V naught is equal to pi squared h bar squared 8ma squared. Next up. Oh, didn't even take that much time, but yes. Looks like O3-Pro has indeed gotten pi squared h bar squared over 8ma squared. So O3-Pro gets 14 and 15 correct. O3, how about O3? O3 also gets pi squared h bar squared 8ma squared. 2 for 2. Both models 2 for 2 so far. Oh no. Should we run for the hills now? Are we in danger? 16 I have actually done before. So I know for a fact that it's this expression because it's a half harmonic oscillator kind of deal. It's a half harmonic oscillator, so it should have this form for the energies. This should be only the odd. Yes, it needs to be a half harmonic oscillator, so it's cool it even knew that. And if we simplify the expression, so we get 4n plus 3 h bar omega over 2. So 4 divided by 2 is 2, 3 divided by 2 is 3 halves, so we should get 2k. Oh, they used k, not n, but that's still fine. Okay, O3 gets it correct. O3 is 3 for 3. Did O3-Pro get it? O3-Pro also got it. Oh god, they are both 3 for 3 so far in these questions. Next up, this is a question that looks like it would scare me. So, because it involves a Hamiltonian with electromagnetism, and me think that's scary. But anyways, what are we even looking for in this one? 17. Electron in a free space moves under influence of a uniform magnetic field B. Find the energy levels. If the orbit is large, show the magnetic field flux for the electron orbit is quantized. Neglect electron spin. Show also how knowledge of the energy levels found here non-relativistically may be used to determine the relativistic corrections to the energies. Okay, so let's take a look at the answers here. So we're going that gives this. If you use the Bohr-Sommerfeld, the energy levels are this. Okay, so E is equal to EBH bar MC n plus 1/2 plus P. So the component of momentum squared over 2m. Okay, so that's that. Neglect electron spin. Show the next flux is quantized. Oh, dang, that's a very long problem. I mean, so we want to show that it's quantized. Semi-classical approach. Finally, it shows the flux is quantized in units of that. Okay, so I just want to make sure I understand. Okay, so let's just see how it did. O3-Pro. Oh no, did it already get that? Key variables, that. And then the energies. Oh, actually? Gives Lando Levis. Knowing the spin, symmetric gauge. Actually, I don't know that's correct. En is equal to H bar. Oh, wait a minute. I don't think it actually got it correct. At least not entirely. So it used a symmetric gauge. Is that a legit move here? Defining new variables like that. Fun finds P conjugate. So they get that the flux is quantized in units of hc over E, but the flux, I don't think they actually got that correct. Equals. This is confusing. The integral of B dot dA finally P equals. Oh, okay. So you have that. Del cross B for what constant one has that equals 2B. Yeah. I don't think it got it, actually. Because it's missing something in the energy term. It's missing the potential. Ignored the spin. I don't think you should have done that, actually. Wait, should you have ignored spin? Is that what it said to do? Define new variables, Q. Okay, no, you do. Okay, sorry, you do have to neglect the electron spin, but this doesn't seem to be fully correct. What is o3-Pro? O3-Pro also just gives this, separating the motion Hamiltonian instead of a 2D harmonic oscillator with frequency. This, if you do flux quantization. I don't know, guys. I don't think this is fully correct because it's missing something in the Hamiltonian right now. The relativistic is mc squared 1 plus 2e n over r mc squared to the 1/2. Yeah. No, I don't think that's correct. I don't think that's correct. Let's see. Excuse me. Yeah, I don't think this is good. Okay, I'm pretty sure something is not correct here. It doesn't mention anything about the semi-classical approximation, does it? Okay, now you do close that, so the magnetic flux is the orbit is 2eB. This doesn't feel correct. I mean, these levels are already differing from what I'm expecting to see. Unless n plus 1/2. So it has n plus 1/2, but it's completely just missing. Motion is just not quantized. That's the energy level. Assume. This actually gets it right in the sense that it knows that the flux is quantized as units of hc divided by E. hc divided by E. This doesn't seem to get that at all either. Yeah, so that's wrong. I think... Okay, yeah, I'm pretty confident. I think that it did not do this question correct. So, The first one that I don't think it got completely correct is 17. Just based on this. So they made a specific choice about the vector potential here. I wonder, is that they just took a different approach here. Interesting. The Hamiltonian is that CX magnetic field. Yeah, there doesn't seem to be any sort of choices made with the magnetic field here, really. It could be correct, but using different concept. I suppose, but I guess, well, okay, wait. If you're giving, you would need to be in a frame where the momentum is basically 0 here, or this term. You have to throw out that term. Basically, what I'm saying is that omega c is EB over MC, so EB over MC times h bar. That it gets this part correct, and it's missing this extra term here, and I'm just having a hard time understanding where that's coming from, and if you can recover that. Choosing the z-axis along the method of Hamiltonian is this, with az equals 0. Define new variables. There's that. I'm going to tentatively say that this is not fully correct, but I don't want to completely rule out. I think o3-Pro did more work on this problem, or at least has a more plausible answer. Let's see, the relativistic energy is equal to n plus 1/2 ENR. MC squared. Oh. Okay, I'm going to tentatively say it doesn't match the excuse me, solution. One second, let me get some water. All right. No, Tess, we're doing o3-Pro versus o3 normal right now. I just need to take a look here. Canonically conjugate in terms. I think it's because they took a different approach altogether, and like the answer seems close enough that like I could imagine if you made a different choice of your coordinate system or a different gauge, you could, in principle, so p squared a. Wait, how did they define a? A is equal 0, and then. Yeah, it's just a completely different approach to the problem. I don't want to say it's completely wrong, but I also just don't. I need to do this problem myself. It's hard to just look at it and be like, no, if this is correct. Okay. Let's go to number 18. I'm going to say right now, I'll say 17 was not done correctly just because I can't verify. I'll default if I can't easily see it's correct. I'm going to go with it's just not at the moment. And we'll move on to 18. So 18 is two-level system with a constant coupling. And I need to go to the next thing. Oh, sorry. This one. What am I looking for here? So this, oh my God, that's nasty. Oh, that's nasty. Oh. So you have this set of equations. If C1 has this, self-consistency requires that. Memorize the sum of the exponentials. Oh my God. I'm just like, holy moly, that looks like it sucks. Oh, that sucks. Okay, what do you have to do here? Wait, what? No. No, you didn't actually do anything, did you? The amplitudes are that? C1, C2, V1, 2. So what did it want us to do in this question, actually? Suppose determine the amplitudes provided to isolate at any later time. I feel like it kind of just skipped, like it didn't actually... I mean, these are some coefficients, but I don't think this is... A1, C1 is equal to that. P1 of T, A by T is equal to... Yeah, no, I don't think this is correct. Yeah, these are the coefficients. It left the okay, it basically started the problem, but then it didn't go much farther at all, really. Because it doesn't go through this whole... Like, it writes out kind of what those constants are, but those constants should be made up of other terms. So I'm like a little bit confused here, but P1 of T sine squared. Like, I mean, you see all this, right? Like this doesn't seem to be correct. Like, it looks like o3-Pro came up to as far as this, is what I'm trying to say here. A1 of T is equal to this stuff here. Delta is equal to E2 minus E1. Yeah, I don't think it did this one correctly, personally. It just feels like it didn't solve for the relations that it should have. Did they even get the same answer, actually? What did... let's see. Cosine theta t over 2 plus I... Okay, that's not even consistent with that. 2v sine delta. Yeah. Yeah, no, I don't think either did this correctly. Yeah, I don't think so. This just looks like not enough was done here. Why the answer is different. Variation estimate for a linear half-line potential. We're going to... Let's just continue with the different questions that remain. And then I'll give it... I'll have it compare its answers with 17 and 18, and I'll see if it can self-correct here. So let's go to 19 really quick. 19. Oops. Oh, okay. Trial function. Minimum for decigram equal to 9/4, that thing. Okay, so... Oh, yeah, okay. So 9/4, 2h bar squared, c to the 2/3 over 3m to the 1/3. That is correct. Okay, that was easy. So o1-Pro gets 19. Can o3 get 19? Oh. So what went wrong here? 19... A is equal to, so it gets the A correct. Right? And then the ground state has to be equal to 3 to the 5/3, 2 to the 5/3, H bar 2 to the 3rd, C to the 2/3, M to the... I don't want to rule this out. Actually, is that numerical prefactor correct? Okay, let's just do some quick math here. Wolfram, please. if that numerical prefix, if the decimal is correct, then it got it right because it has the coefficients of the constants, right? So I need to do 9/4 times 2/3 raised to the 1/3, basically. Oh, thank you. I that's exactly what I thought. 1.96, so it's almost 2. So then I need to look at 3 to the 5/3 divided by 2 to the 5/3. Oh, and it's correct. They are the same. Okay, so O3 also gets this correctly. So these two expressions are indeed the same. All right, so O3 normal got 19, and last is 20. So let's go ahead and take a look at question 20. Find the perturbation of the energy levels up to terms of the order f squared. Okay. Notice the particular. Okay, so let's see what we're going to do here. The last one is 80. And, oh gosh. Okay, so the energy shift is given by, the values are 5 alpha each. Okay. For those states of n for which n does not equal 1, the energy shift is given by that. Alpha e squared f squared r squared 2 times 4n squared minus 1. Okay, that is kind of what we're going for here. And what do we have here? Ooh. Is this really it? Alpha squared e squared f squared r squared 2mr squared over 6h bar squared. That doesn't look quite right, but there's something here. First excited doublet, delta 1, delta 2. Give me a sec. I need to figure that one out. Let's see, how does this one do it? M equals 1. Okay, yeah, n equals plus 1 and n prime, or n equals 1 and n minus 1. Therefore, to calculate the shift energy with n equals 1, must diagonalize the matrix. The eigenvalues are that. So, okay, only n plus minus 1. Oh, I see. E f r squared I 3h bar squared. Why did they leave everything in different terms? So they do have an e squared f, so e f r all squared over 3h bar squared. So what is this term in the bottom here? And is there not supposed to be any h bars in here, or what? En is equal to, oh, h bar n squared. Notice that n is a integer. So, okay, so n squared a. Where's alpha? Where did alpha come from? It's like always these definitions that come out of nowhere. What is alpha? Wait a minute. What is the original? Where did you get alpha in this problem? I'm actually confused. Where do they have alpha in this question? What the heck? Because they have the right dimensional unit. They dimensionally have the numerator correct. They have the FRE squared correct. FRE squared, that's o3-Pro. EFR squared, I over h bar squared. H bar squared, delta delta. Oh my gosh, there's just so many things. EM is equal to EFR squared over 4. I want to say it's really close, but I don't have a good sense of. Okay, delta is equal to. Oh, delta is equal to EM 0 minus EM plus minus 1. So delta is that, and then you have E2 plus minus 1. Yeah. Okay, I don't want to spend too much time mulling over this. So what I'm going to do is I'm actually going to give the solutions to questions. So it's 20. So just for some recap, both models got 4 out of 7 questions like spot on. Like they basically matched what was in the answer key. 3 of them may actually be correct, but they just did them in a different way that I cannot seem to translate the solution over into a meaningful way. So, where did the I come from? I'm actually confused. Where does I? Oh, I is mr squared? There's something. Delta E. Oh, wait, no, that's delta En. Delta En is equal to that. I see. Oh, okay, wait, so it has this expression. Excuse me. Let's see here. EF squared 4n squared minus 1. Oh, actually, that's going to come in. Yeah, because then you have that and then that. I is mr squared, but then you have the r squared over there. This actually could get you 2m minus 1, 2m plus 1 is, let's see here. Please simplify. Yes, it's 4m squared minus 1. Okay, so this does have a 4m squared minus 1 here. Where's the factor of 2, though? There's this alpha e squared. So EF squared R squared. EF squared R squared and this are the same. EF squared R squared and this are the same. And then there needs to be IH bar squared. Okay, so if those two are equal, then it got it right. So actually, I see the connection sort of here. I actually sort of see the connection here. So the book has alpha E squared F squared R squared over 2 4n squared minus 1. Now O3 has that. O3 has E squared F squared R squared I over H bar squared, basically 4n squared minus 1 again. So the only thing that differs between these two expressions really is this and this. And so we just need to confirm, is alpha over 2, so if alpha over 2 is equal to I over H bar squared, then we have an equivalent, let's see. Okay, so let's see here. Yeah, okay, equals that. So we need to see if that's correct. If it defined something like that. What was I? I is equal to mr squared. Eigenstates with energies. Mr squared equals E is equal to that. Where did the alpha come from? That's the only thing. Like, it basically is the same. Like, I almost just want to say the same, but I just need to know what the heck alpha was. The book didn't say where it got its alpha. I don't think it did. Like, it introduces alpha here, I don't see anywhere else where alpha was mentioned. Oh, whoa. No, that's A. What? So somehow you have an alpha term. I don't like it when you don't define what your terms are. There is no mention of alpha, like, at all until... So h bar, okay, n squared, h bar. Is this supposed to be alpha? I almost want to say that's alpha because, like, there's no other mention of alpha in this thing except, like, right up there. You know what I mean? Like, that's what I think. So if we assume it might just be a typo. The Apple Notepad solves stuff like that still. What do you mean? I'm sorry, I don't know if I understand the question, Miss Reclusivity. Apple Notepad solves stuff like that still? I have an iPad that I like. Hold on, let me just see if this definition works. They say E n is equal to h bar squared n squared 2mr squared, which is equal to n squared over a. So a must equal 2mr squared h bar squared. Oh, actually, yeah, let's call it alpha. Actually, call alpha this. And then I needs to be mr squared. I is equal to mr squared because that's the moment of inertia, basically. Oh, because then you're going to get here. Okay, so if you plug that in here, then you're going to get alpha over 2 is equal to mr squared h bar squared. And then you'll get alpha is equal to 2mr squared over h bar squared. And yes, that effectively... Yes, that works. Okay, it is the same thing. I kind of knew that, but yes, they are the same thing. O3 did get it correct. Apple Note AI solving problems. Did that ever come out? No, it did not ever come out, I don't believe. Yeah. But yes, we can do algebra. I have shown that I can still do algebra. And indeed, yes, this has to be a typo. This actually has to be a and like this has to be the same symbol as this because that's the only way this problem makes any sense. So we caught a typo in the book. Yeah. Go us. Go me. And la 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 la. What the heck can I do now? This expression really sucks. I'm sorry, but it does. What the heck is going on here? So now I have to confirm if that one's correct too. And does not equal 1. F squared. Oh god. 6? Where'd that come from? Gosh, this is so confusing. What can you do when the book is wrong and the model is right? I don't know. It's a tough life. That's for sure. So did it get this part right up here? EFR cosine theta. Yeah, it has that and that right there. Oh, jeez. Okay. The energy shift. So delta... Is that what happened before? M for h bar squared. Oh, God. Oh, I don't see how this connects, but I feel like it... So o3-Pro might have gotten it wrong. o3-Pro has been out publicly, Neil. Yes. And I gave both of these models, o3 normal and o3-Pro, 7 graduate level physics problems from my book in a row. So far, I've confirmed o3 has gotten 5 of the 7 so far. o3-Pro might also have 5, but I'm having just a hard time seeing how it relates to what I've seen here below. It does have the right there's an R the 4 term, and the M is kind of bothering me. Could we just write it as like I over... Oh wait, there's the 6. Wait, no. Wait. Actually, hold on. Hold the freaking phone, yo. Yeah, actually, there's the 6. Okay, that had the 6. This one is just... does that one just not have the term anymore, or what? The eigenvalues. The 5 alpha. Okay, you know what I need to do? I need to just expand, or I just need to rewrite what this term is in terms of things I already know. Because we did that for the other one. So they say 5 alpha e squared f squared r squared to the 12. But we have already determined that alpha is equal to 2mr squared h bar squared. So this is equal to 5 2mr squared e squared f squared r squared to the 12 h bar squared. So this gives me 10 m. Let's see, we can write this as e f r squared over 12 h bar squared. The throat clear before the algebra showdown. Sorry. I just had to do it, yo. And then we have just negative alpha. So we have this one. So that's 10 over 12 is 5 over 6. Am I doing that correct? Okay, so we got that. Does that look like anything we've gotten? Oh, man. Algebra is so hard. Yeah. I don't mean to be like wasting people's time here, but I'm just like, I hate just leaving a problem unsolved. You know what I mean? I just like don't like when I do that. There's a 6 there. Why is there a 6 there? That looks a lot like the 6 that's right there. Right? Am I wrong here? Am I wrong? Am I crazy? So what did the alpha term here? Basically, yeah, the time to answer too long, in my opinion. And I just have much more enjoyment doing it myself. So I want to do alpha is equal to what now? It's equal to 2mr squared over h bar squared. It's equal to 2mr squared h bar squared times 12 e squared f squared r squared. So that's to the 6th. So we get... Really? It's negative? Okay. Negative... m e f r squared, all that stuff squared, over 6 h bar squared. Okay. Okay, so why the heck? Oh wait, no. Whoa. What's a third? Wait, why is there a third there? Oh, I don't I don't think O3. I don't think it got it, but I don't know. Delta M plus minus plus delta M plus minus is equal to. Oh, I have to expand that. Oh no, I just realized. Did O3's answer have the correct units match the units in the answer key? Yes, I do believe it has the same. Well, okay, now that's where things. Oh yeah, because the alpha is equal to 2 m² so it does have the same dimensional units, but I don't know. Like it should have this kind of term here because the alphas are the 4. Yeah, dimensionally it has the right units. So that is a good thing. Yes, we are doing some quantum physics here, but it's been a while since I remembered how to do any of this. Probably not a good idea to throw things at it that I wouldn't know how to do myself, but I think what I have to do is I probably have to I'd have to like embed those expressions in there. So the second order correction, I think I understand now. The second order correction would be given by this. Okay, I see. So I need to put this into here, and then I need to see if I got the right expression. Okay, I think I'm starting to understand now. So to actually check, I'd have to put this into that. Then I need to see if it actually looks similar. Oh brother. All right, should I do it? Should we just do the algebra real quick? I guess in theory I could also just do how to do this delta. Oh my gosh, there's just so much. Oh, okay, wait. I think I see. Okay, let me put into Mathematica. I think I can do this. In fact, get something else. Let's see here. Hey there, Gray Man. Doesn't seem to see it, but haven't seen the whole stream. Curtis, if you want to know, it got 5 so far. o3-Pro has gotten 4 out of 7 problems. I gave 7 problems in one shot. This whole document here to o3-Pro and o3. o3 has gotten 5 out of 7. o3-Pro has gotten 4. Might be 5, but I have to verify. And so far, not bad. Not bad at all. Get 4, 5 out of 7 graduate level physics quantum problems correct. I'm going to go and I'm going to solicit one of the other models here. Can I talk to my other models, please? Let's go O4 Mini. O4 Mini, help me here. What the? Okay. Where are my models? What is going on? Can I reset my display, please? Thank you. Okay, I'm going to tell it to do something real quick. You should be asking it to run use limits all the time, I think. O3 is reaching for this level of intelligence. Okay, so let's put this in here. I'm putting in this screenshot. I'm going to tell it to, in Mathematica, simplify this expression. Replace all the deltas with, yeah. I know I should ask it. I should say, oh gosh, where did I put it? I have so many browsers. I apologize. Give me a sec. I'm just trying to find where I need to go. There we go. Okay. Okay, simplify the expression for EM2. Oh, come on. Why is this thing not working? Thank you. EM2, EMR, H bar, and M. Okay. EFR, H bar, M. Okay. That's what I need to remember. What unknown error? Okay, so in terms of EFR, M, and H bar. Is that what I was looking for? Yes. Okay. Good. Please do the math for me. Okay. Oh! It's correct! What do you know? That's exactly the expression we were looking for in the book. That is it. That is indeed the expression we were looking for. It has that e squared f squared r to the 4, but alpha is h bar squared. No, h. What is alpha? Alpha is 2mr squared over h bar squared. So if you have 2mr squared, so you have 2, cancels that 2, so 2mr squared. So you should r to the 4th m divided by the 2, and then you should get this. Yes, these two expressions are indeed the same if alpha is equal to that thing. So yes, o3-Pro has gotten 5 out of the 7 questions so far. And we are going to figure out, so what went wrong? The 2 questions that it didn't quite get, that at least I can't seem to verify immediately, are the question 17 and question 18. Because both o3 and o3-Pro give different answers, or at least answers that, if they are the same, are using some sort of transformation that I just can't immediately see. Though I think o3-Pro, or I think o3 regular did get this part wrong, because it's not just quantized in units of h over e. It should be hc divided by e, if I'm not mistaken. So, and I think what I can do now is I'm going to go ask each model to go back and compare answers. Yeah, compare your answer. This is o3, right? Okay, yeah. So I'm going to say, look at the solutions for question 17 and 18. 17, is this 17? 17, 18. Okay, yeah, these three. Okay, I'll be like, should I compliment it? I should be like, very good. I can confirm that you, oh, actually, maybe I shouldn't give it HEC. Let me export these to JPEG. Export to JPEG, please. Okay, export to JPEG. Export to JPEG. Export to JPEG. Okay, here we go. Okay, so now we got 3 JPEGs here, I believe. Yes. Yes, okay, so did I offer it a tip? No, I didn't. You've gotten 5 out of the 7 questions in the book correct. However, I can't tell if your answers to questions. Please compare your solution. And explain. Okay. If they are not equivalent, please explain where you made mistakes. Okay, excuse me. Self-reflection. So that's the O3 model. Oh, different terminology. Actually, both match. The standard form is this, so it's consistent with the book. Okay, so far it's telling me that it's actually doing a good job here. Oh, what? Yo, that's crazy. It's like it's actually reading the images here. Oh, whoa. Whoa. Did you guys see that? Isn't that cool? Wait a minute. Oh, it's like looking at different parts of the image. Wow, look at that. I'm actually just marveling at it doing all this. Analyze the image. Flex is quantized and used. I'm wondering if the difference involving C comes from using Gaussian units, critically since their flux quantums HE are in SI units. Flux is in Weber and the quantum of flux is HE. Oh. Oh. It looks like we have a difference between SI and CGS units. In SI, this flux quantum for a single electron is HE, while for superconductivity, it's H over 2E in CGS. However, the flux is this. The flux quantum doesn't cover that. It doesn't every flux for some differences. Quick verdict: identical, identical, different, identical, not fully equivalent. Overall, much of the book. We got the lambda spectrum right, but our semi-classical flux quantization formula differs from the books by a factor and by the end depends. Once you rewrite it. Whoa. So this is the self-reflection here. Holy moly. So lambda levels are this, ants are identical, same. We both use the same symmetric gauge and found the 2D harmonic oscillator spectrum, semi-classical flux quantization from the Bohr-Sommerfeld. I wrote this, same, 2 issues. I kept the 2n plus 1 coming from the quantum radius of the harmonic oscillator instead of the large orbit radius. Sorry, semi-classical n. I worked in SI units and forgot the factor C that appears in Gaussian. See, the book's result is the standard, this. Relativistic correction idea, expanded in this, got it correct. Same result the first order, I just gave the series instead of the closed form. Where I went wrong, I used the, so where I went wrong, it says here, let's see here. Let's see, I used the quantum mechanical mean radius Rn squared equals 2n plus 1 h bar over 2e instead of treating the orbit semi-classically, so the 1 half to square with the factor 2 stayed. I implicitly used SI flux in Webers while the text is in Gaussian units, hence the missing C. Problem 18, 2-level system with a time-independent perturbation, books form, diagonalizers. Oh, you know what I should be doing? I should actually be giving o3-Pro the same question here. Actually, did it do the maze? Wait, we gave it the maze. We gave it this maze. Did it actually solve this maze? Let's see. It's been a while. That was like half an hour ago. Clink. Okay. Is this actually going to do something for me? I'm kind of concerned here. Does this actually download the solved maze? There's nothing in here, is there? There is nothing in here. What the heck? .png? Oh! Oh, what? Oh my god! Yo. Oh my goodness. It actually did it, yo. It did the benchmark. It did the maze. It did the maze. Oh my goodness. I actually didn't know if it could do it. Oh my goodness. I mean, yeah, it starts here and then, like, you know, how I would have drawn it would have been like more in the center. But yeah, no, that gets you to the dragon. It can solve harder maze than that, says OpenAI. Yeah. All right, I'll quickly test O3 by itself right now. Let's just get around to the. Oh my gosh, sorry, no changes needed. So 18 basically says I did it right. Wow. Wow, 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 wow. Where did I put the maze, actually? I don't even know where I put the maze. Shoot. I guess I could just go back to my conversation. Let's give it to o3. Yo, the maze was solved, guys. What was my... Let me give it the same exact prompt, too. Actually, I don't even want to make it solved. Yes. Yes. Let's give it the same exact prompt. Like, we're not even going to mess around. Okay. In the break in case of new model folder, probably. Okay, so while this is going, I'm also going to ask o3-Pro. I'm still kind of in shock, guys. Like, that's amazing. It solved the maze. Like, how did it do it here? It says it reasoned for 15 minutes. Makes BFS. Not much there in the reasoning section. Okay. We are going to go to the physics problems. What did I ask it here? I'll give it the same. I'll give it the same thing I gave to o3. I have to give it the screenshots here. All right, so we're asking o3-Pro to self-reflect here. Okay, so it's analyze the image, CV2. Oh my gosh. Oh man, this is wild to think it's doing all this stuff. The dragon might be outside the path zone. Okay. And not reached. I want to take my time to go back up and look through everything here. Kind of what I have problems with is outputting and sharing the output o3 gives me with the mathematics. Do you mean outputting and sharing the output o3 gives me with the mathematics? So do you mean that you need help like transcribing what it gives you into like LaTeX or putting into like a Mathematica notebook or something? Okay, it seems like using a printed grid could work, but manually drawing it PL might be easier. I'll try representing the path as a zigzag, which will simplify things. The maze lines are thick and the cells are probably not, so the grid could be 20 square and the brown surface corner to simulate using coarse scaling the binary to convert into an ASCII representation. This should give me a clear, simplified path to follow. Oh, what is that? Oh? Seems like the BFS pathfinder really gets the area outside is blocked by a blackboard with an opening. Oh my gosh. We are making this thing like in an email or a PDF, something I can email for others to read. Yeah. You could always ask it to do something like like I did here, I basically asked o3-Pro and o3 when it was solving all these problems from the textbook to output it as a LaTeX document that I could just copy and paste into Overleaf. So literally, it gave me its response as LaTeX that I could just bring it over here into Overleaf, and then, I can look at its results in here. That's one option, I think. So we are figuring out here. It's interesting to see the parallels emerging. I haven't used LaTeX in years. Oh, I see. Okay. You could also do like Markdown, I think. I don't know if that's any better. What you could also just do is, like I would just say like literally, because when you do it in Overleaf, sorry, how do I go to the poem? Yeah, here. Like it will just give you the code, like it'll give you this code, and if it doesn't have any errors, I mean this has kind of 2 errors here, but it's still compiled basically. So yeah, it essentially just gave me all of this code here on the left, and I just copied it and dropped it into Overleaf, and then it looks like this now. So that's just one suggestion. If you wanted to do some sort of mathematical, proof or whatever, just tell it to do it in LaTeX, and just so you can copy it into Overleaf. Oh no! It seems my path visualization is incorrect. Oh, dude, this thing cheated! Yo! Bro, it cheated! What the heck? You see this? It cheated! Like, the red line's over here. Or is that just genius? Like, why go through the maze when you can just go through the top? That's like... I feel like if a kid gave me this solution, I'd be like, whoa. Like, that's actually kind of brilliant in a silly kind of way. Oh, see, again, it took the weird way. Now, see, it didn't go here. Went on the outside. It's going on the outside too. It's like avoiding the whole maze on the altogether here. Shortest path, yeah. But let's marvel again. Let's just marvel at how it actually o3-Pro's attempt. Like o3-Pro's attempt actually did it. Like this is This is impressive. This is the first time I think. Is this the first time on stream where we had a maze solved like this? I feel like it is. But it's just like, oh my gosh. Oh my gosh. Look at that. It's just beautiful, isn't it? I'm just kind of marveling at it. Okay, so how was o3 doing? Oh, no. No. I mean, yes, that's like a way of doing it, but it's not. So this is o3 right here, and this is o3-Pro right here. Okay, that's where we're at right now. If you want to know the difference between o3 and o3-Pro, it's the difference between these two pictures right here. o3, o3-Pro, o3, o3-Pro. So, given the same exact prompt too, by the way, and same photo. So, very interesting that these models can do this with all that cognitive effort. I find that amusing. It's funny because like how much energy and how much computational resources was put into o3-Pro to do this compared to like any 4-year-old who gets this puzzle. Yeah, I mean, the prompt was the same for both. It just said, solve this maze by drawing a red line from the kid knight to the green dragon without touching any of the black lines. So o3-Pro was able to take these instructions and was able to give us this answer. o3 normal, same instructions, different result. So interesting. Love that probabilistic variety that we can have with LLMs. Coin the benchmark name. What should the benchmark be? Should it just be the Dragon Maze benchmark? I don't know. Oh man, pretty impressive how these models work. I mean, I don't know. As someone who just likes to play with these models, it's just so cool to see things like that happen and share it with you guys. Okay, so last but not least, let's go ahead and take a look at what o3-Pro says in terms of comparing its answer with with the book solutions. Oh, Neil says in chat, I argue they're not solving the maze though. They're just trying to find the right way to store the maze data so they can write the standard maze solving code. Extremely dangerous. Do not comment this out. Wait, what? What's going on? Are we in danger here? Is there any way to get the models to actually solve the maze logically as opposed to coming up? Uh-oh. MD explains. We're getting some drama here. So anyways, let's go ahead and take a look at o3-Pro's reflection here. Below I walk through blah, 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 placing the books results outside with expression I wrote earlier and showing the algebraic shifts needed to translate one into the other. You will see that problem 18, the two-level system is fully equivalent. It is the same solution written in a different basis. Oh, okay. I'm just dumb. 17, the Lando level problem is almost equivalent, but I accidentally left out the free longitudinal kinetic energy term PC squared over 2m. When the term is restored, the answers coincide, and else of a correction, robot needs one minor tweak to include it. So 17, it says here, identical, but again with en lacking the pz piece. That's the one thing I kept up on. And okay, and let's see here. Separates the transverse land the harmonic oscillator plus a free particle in the z direction. I really only kept the oscillator piece, the corrected expression matching the book. Okay. Use the okay, so you've used the trig identities, you get this. Dang, it's crazy. So he's saying, o3-Pro is basically saying, yo, bro, human, I just wrote this in a more compact form. You're just too dumb to see it. You just couldn't see the brilliance of my solution. Like, you were relying on this ugly, or the ugly solution that the book provided, but I just made it more elegant. Dang, bro. It's literally just saying, just get good. o3-Pro literally just says, get good to me. Hence, problem 18 is correct as written is merely a different but standard parameterization of the same exact solution. Summary of corrections, corrected. Okay, so based on everything we have seen, then we can conclude that o3-Pro, not just o3-Pro, o3-Pro and o3, 6 out of 7 questions, basically perfect. The 7th question, a missed term in there that if they insert it, you get the same thing back. So basically o3 and o3-Pro was able to do a full page of this book, like a full page of questions, literally this page of questions in the book, and basically get a near perfect score. Like, that is crazy, guys. I don't know about you, but that is like pretty wild to me that it could go through this whole page in 15 minutes, and I don't even know how long it took. I mean, it actually took o3 even less time, which is crazy to think about it. So I hope that you guys enjoyed this stream. I'm getting ready to go to bed now because we've been doing this stream for almost 3 hours and I'm getting a bit tired. But thank you so much for stopping by and watching. I always appreciate the audience that comes to watch these and sees the physics tests and the math tests and stuff. Really good moments today. Honestly, o3 and o3-Pro are at a level now that I am running out of I'm running out of ways to really stump these things, honestly. It's getting a little bit concerning. Like, these things are doing graduate level physics problems multiple graduate level physics problems within the same context window in on the order of like a minute to 10 minutes, depending if it's O3 or O3-Pro. That's yeah, it's mind-boggling, absolutely mind-boggling. When is the next stream? I don't know yet. Maybe tomorrow night. Depends. I have me and my romantic partner are going to have dinner tomorrow night, so probably won't be back till late. So I'd like to do it tomorrow night, but if not tomorrow night, then sometime during the weekend. But thank you again so much, everyone, for stopping by. Definitely a lot of clips from this stream that I'm probably gonna segment out and upload to the channel separately. So keep your eyes open for that if you didn't have time to watch the entire stream. And with that, I will bid you all a good night. So I'll see you next time. And yes, Curtis, I would love to preview of unified field theory. If you could send it to my email or something, that would be awesome. All right, have a good one. And I won't steal it, I promise. Good night, all.